take a moment and picture a simple lock on a door. Classic security thinking says, the door is either locked or unlocked. Inside is safe, outside is not. That's the world many systems were built for. But the real world rarely fits such black and white rules. Sometimes the courier who needs to deliver a package should be allowed through the door, but only between 9 and 5, and only if they show the right badge. Sometimes a monitoring script needs to reach into the database, but only to read a tiny, redactable slice of data. Real systems need nuance, conditional, time-bound, and context-aware trust. That nuance is what we mean by partial trust, and the modern operationalization of that idea is called zero trust. At its heart, partial trust is a recognition. Trust is not binary. Instead of asking, do we trust X, we ask, in what ways, for how long, and under what evidence do we trust X? Zero trust takes that question and turns it into design. Assume nothing is trusted by default, require proof for every access, and scope what is allowed precisely. Why does that matter? Because attackers don't need you to fail spectacularly. They only need you to be convenient, a permanent broad credential in a config file, an API that accepts calls from any internal host, an automation pipeline that runs arbitrary code with production privileges. Those conveniences are cracks. Partial trust closes those cracks by making every crossing conditional, observable, and limited. Let's make this concrete. Imagine a service A that needs to call service B to fetch customer records. The old model, both services live in a trusted internal network. Service A has static credentials and can call B freely. In a partial trust model, service A must present short-lived, cryptographically verifiable credentials that assert who it is, what action it's requesting, why it needs that action now, and what constraints apply to the response. Service B enforces policy, scope, fields, rate, and logs the access with a correlation ID. If any part of that proof is missing or stale, the request is denied. There are several practical patterns that make partial trust work: ephemeral credentials and just-in-time JAK access. Instead of long-lived keys, issue tokens that expire quickly and must be re-requested. For human access, require short-granted elevation. For machines, prefer short-lived tokens minted by an identity broker tied to machine attestation. Fine-grained authorization, attribute-based access control. Use attributes, requester identity, request context, resource sensitivity, time of day, device posture to decide. Attribute-based access control lets you express rules like allow read if requester is service A, resource tag is non-sensitive, and the request originates from an attested host. Mutual, cryptographic identity on every hop. Use mTLS or signed tokens so every service can cryptographically verify the caller. Don't rely on network location. A certificate issued by a short-lived PKI tied to your orchestration system gives each workload a solid, verifiable identity. Least privilege by default with narrow exceptions. Start with deny all and open only the smallest, most specific doors needed. If a process only needs one column in a table, give it only that column. If it needs to call one API method, only allow that method and no others. Transform and redact at boundaries. When returning data across a boundary, minimize what leaves. Redact PI, return only aggregated results when possible, and avoid sending raw credentials or secrets downstream. Continuous attestation and posture checks. Trust shouldn't be a one-time handshake. Use device posture, runtime integrity checks, or service attestations to re-evaluate trust continuously. If a container's image digest changes or a host fails a health attestation, reduce its privileges immediately. Policy as code and automation. Express access policies in code, put them in CI, and enforce them with policy engines at runtime. That ensures consistency, auditability, and avoids the someone changed a rule in the console drift. These patterns sound great in principle. The trick is in the implementation and the trade-offs. Partial trust introduces friction, more tokens minted, more checks performed, more latency added. So design choices matter. Which boundaries get strict enforcement, which get lightweight checks, and where do you accept some risk for operational simplicity? A useful way to think about trade-offs is the value-to-risk curve. For low-value operations, simple checks may suffice. For high-value resources, secrets, payments, identity, invest in full attestation and multi-factor authorization. The key is to map assets to protection levels and then map protection patterns to those levels. Let's walk through a short story to see partial trust in action. A developer needs temporary elevated access to a production database for an urgent bug fix. Old school, they ask an administrator who hands a key that never expires. New model, the developer requests a JIT role via the identity portal, which requires MFA, an auditable justification, and approval from a second person. The system issues a scoped token valid for 30 minutes, tied to the developer's device attestation. The token allows read-only access to a specific subset of rows. All activity is logged and sampled for live monitoring. After 30 minutes, the token expires and any sideways movement attempt fails. The net effect, the developer can do the work, but the window and scope are limited and observable. Another practical area where partial trust shines is in service mesh architectures. A service mesh acts as a network-level policy enforcement plane that mints and verifies identities, performs mutual TLS, and can inject policy checks, rate limiting, ABAC transformations. Instead of trusting the network, you trust the mesh to require proof on every request. That's powerful, but also demands correct mesh configuration, strong identity issuance, and telemetry that integrates into your detection tooling. Partial trust also reframes the concept of zero trust. Zero trust is less a single technology and more a philosophy expressed through patterns. Never trust by default, always verify, and minimize the blast radius of any granted trust. It doesn't mean you never trust anything. It means every grant is conditional, constrained, and observable. There are common implementation anti-patterns to avoid. Don't misapply zero trust as a firewall replacement slogan. Network controls remain valuable, but insufficient. Don't centralize policy decisions in a single heavyweight component that becomes a performance bottleneck or single point of failure. And don't mistake identity for authorization. Strong identity is necessary, but not sufficient. You must still evaluate intent, scope, and resource-level policies. Monitoring and feedback loops are essential. Because partial trust is conditional, you must measure when conditions change. Implement telemetry that captures attributes used in decisions, device posture, token issuer, request path, and the result of policy evaluation. Build alerts for anomalous changes in these attributes, sudden spikes in JIT requests, tokens requested from unexpected locations, or an unusual pattern of data redaction bypasses. Adopting partial trust is also an organizational challenge. It requires policy discipline, automation, and often cultural change. Teams must accept shorter-lived credentials, more frequent attestation steps, and stricter CI gates. But it also reduces firefighting. When trust is conditional and observable, incidents are smaller, faster to detect, and simpler to remediate. To summarize practical next steps you can take today. Start with identity. Ensure every workload has a short-lived cryptographic identity. Move long-lived credentials out of code. Use vaults and ephemeral tokens. Introduce JIT elevation for human and machine privileges. Implement ABAC or policy engines where you need fine-grained decisions. Put mTLS or signed tokens on the critical internal APIs. Instrument attribute telemetry and alert on abnormal patterns. Express policy as code and enforce it via CI and runtime guards. Partial trust and zero trust aren't a single switch you flip. They are a design path you walk. Tighten the highest risk boundaries first, automate the rest, and make every grant conditional, minimal, and observable. If you leave this video with one mental image, let it be this. Don't think of trust as a key you hand out and forget. Think of trust as a ticket. It should say who, why, for how long, and what it allows, and it should expire.